Today we will discuss the next application of Coriolis and centrifugal force, that is Foucault's pendulum. Foucault's pendulum. This is a pendulum which demonstrates the rotation of the earth. It demonstrates the rotation of the earth. Rotation of earth. We all know that earth is rotating about its own axis and it completes its one rotation in 24 hours about its own axis. So this Foucault pendulum is used to study or to demonstrate the rotation of the earth. We will find what will be the path followed by the earth during rotation and what will be the time taken to complete one rotation, that is 24 hours and elliptical path. You know that we already know the result because we have studied the rotation of earth in detail in the lower classes, that is the path followed by is elliptical path or elliptical, and second time is 24 hours. So there are two results which will be proved by this article or this Foucault's pendulum. Foucault is the name of scientist. So this is a simple pendulum. I don't know what used for a simple pendulum. Basically, it is specially designed pendulum or simple pendulum. It is basically simple pendulum having very heavy mass. Heavy mass. You know that this is the pendulum. It is mass. It is string or thread. So in case of Foucault's pendulum, in this case this mass is very heavy. It is in kilograms and string is very long. Heavy mass and very long string. So string is in kilometers. It is very long string and very heavy mass, and it's free to swing in any direction. Is free to swing in any direction. There is no any direction confined for this pendulum. It can swing in any direction. So this pendulum is swinging like this. With a pendulum, it will swing like this. So with the passage of time, it will change its direction ultimately because it is moving under the effect of gravity on the earth. As we know, the earth completes its one rotation in 24 hours. Therefore, this pendulum is also vibrating and its plane of vibration, this one, plane of vibration is also rotating along with the rotation of earth. It also complete one rotation and the plane of vibration also complete one rotation in 24 hours. So this is basically demonstration for the Foucault's pendulum. So it's clear, very simple pendulum, but the parameters are very special. That is, first parameter, heavy mass. Second parameter, very long string. And third parameter, it is free to swing in any direction. So it is called Foucault's pendulum. So this pendulum is specially designed for demonstration of the rotation of earth. That is, these two results will be obtained from this pendulum. So we will study the motion of this pendulum, but we will prove these two results. So this is our question, this is our answer. So Foucault pendulum. So it is practically or designed by the French scientist Foucault. So for study, we will draw a diagram. Let this is Earth, and there is a point origin O and point P. or this point may be N. And the line joining between N and this point, that this point is S. S means point of suspension. So this is a point where pendulum is suspended. So from here it is very long string and very heavy mass which is vibrating in this plane. This is mass, this is pendulum. It is vibrating like this. You know that it is vibrating about the effect of gravity. So this is the center of Earth towards which gravity is occurred. So this pendulum is vibrating like this in this plane. So this is pendulum. So let the point position is A, this position is B, and this point is P, and this point is N. So this N point is very close to P. You know that when we study mathematically any pendulum, then it is considered that, it is assumed that it should be very near to the surface of Earth. Okay? And its plane of vibration or the amplitude of vibration must be small. You know that there are two constraints, two conditions. First one is it is very near to surface of Earth. Surface of Earth. And second one is the amplitude of vibration must be very small. Very small means it will sting in very small vibrations. It will not move like this. It will move like this in a slow motion. Why? Because we will consider the path A to B. It is just straight line. So it is equal to straight line. Actually it is curve. But when its amplitude is small, then this distance is very small, then this arc and is equal to AB length. So we have to consider AB as straight line. Therefore, the amplitude must be very small and is very close to surface of Earth, because we consider the gravity on Earth and is same as the gravity at point P. So P is very near to N. These are two conditions for simple pendulum. So these conditions are already known to you. Now we will prepare equation of motion. What is the equation of motion? Equation of motion. You know that when we study any pendulum, then we have to draw or prepare an equation of motion. What is equation of motion? It is the motion of number of forces acting on the pendulum. So we will consider different number of forces. So what will be the force? What will be the forces which are acting on the pendulum? So there are four forces. First force is weight. Weight of pendulum. You know that weight is mg. When there is a mass, then gravity, as due to gravity is acting on it, then the weight become mg. So this is mg weight. Second force, you know that weight is a force, and second force is tension in the string. Tension in the string. Mass has weight and string has tension. And you suspend any mass with the string, then string is stretched. It means it experiences a tension. So tension, second force. Third force is centrifugal force or Coriolis force. It is Coriolis force because this pendulum is installed on the earth. Therefore, the Coriolis force as well as centrifugal force both will act on it. The centrifugal is Coriolis force, that is F Coriolis, COR. And fourth one is centrifugal force, that is F centrifugal. So there are four forces. Two forces are due to mass and string, and two forces are pseudo forces or fictitious forces, that is Coriolis and centrifugal force. These are applied by earth and these forces are acting on the pendulum. So overall there are four forces acting on the pendulum. So the equation, we will form the equation. So equation means net equation, the net force acting on this pendulum is, let that force is F. This is called net force or resultant force F. F is equal to this one. That will be F1. It is F2. This is F3, and this is F4. Means 4 forces. All are forces. So F is equal to F1 plus F2 plus F3 plus F4. So this is simple equation of motion. And we put the value of these F1. What is F1? It is m into g vector plus F2 means T vector tension plus F3 means F Coriolis force. What is Coriolis force? It is minus, write it as minus 2m omega cross V, and centrifugal force, it is m omega cross R. Okay. So 1, 2, 3, 4. There are 4 forces. So we know the value of centrifugal force, Coriolis force, and centrifugal force. So I put the values of these forces, and we will solve these all vectors into their components, as we are already doing this type of work in the previous articles. So here net force F, it is equal to F. So F may be written as m into A. A means any acceleration, net acceleration. It is mg plus T minus 2m omega cross V minus m omega cross R. All these are forces. So this is the equation of motion. That is equation is number 1. Or we can cancel this m is common in 3 terms, but there is no common m. So we will cancel this m later on. Now we will split the vectors, all vectors, this one, and these vectors. Let this term as 0. Why? Because this term contains omega into omega. As omega is very small, we have already assumed that, and omega square, when you multiply omega with omega, it will become omega square. Omega square tends to 0, therefore this term can be neglected. So this term can be omitted from this equation. So that equation become m into A equal to m into g plus T minus 2 omega cross V. Okay, this term is 0. This term is 0. So this is final term. Now we have to split all these vectors, only vector quantities, into their components. What will the components? G. So what is G? Here, G vector is equal to magnitude G into direction of G. You know that G is acting on toward the center of Earth, and along this side, this is Z axis, this is Y axis, and X axis is inward, as we have already considered these axes in previous article, in Coriolis force article. So same coordinate system is used in Foucault's pendulum. This is Z axis, it is Y axis, and X axis is lying in inward direction. So Z means due to gravity is acting on this side, and it is negative to Z axis. So it will become G into minus K. That is minus G into K. This is value of G. And what is value of T? So we have to prove what will be the value of T. So I will prove this T value after some time. First of all, we have to take omega vector. What is omega? Omega is, you know that omega is lying this side, because there is Earth and this vector is omega vector. If it was omega vector at this point, it will become omega, and the angle is this lambda. Therefore, omega is lying in the YZ plane, as we have studied in the previous article. So it will become omega cos lambda into j, omega cos lambda into j plus omega sin lambda into k, because omega is lying in YZ plane. So split omega in two vectors, two components, sorry. It is G value, the value of omega, and value of V. What is V? V is the velocity of this pendulum. So this velocity is variable because this pendulum is moving like this and its velocity is varying. Therefore, velocity taken as, in general case, x dot I plus y dot j plus z dot k, which we have already used in Cartesian system. Velocity has three components: x dot I, y dot j, z dot k. So we have split the g vector, omega vector and v vector in components. Now it is turn to split t vector. What is t vector? The t vector is this one. I am writing this t vector as t magnitude into t cap direction. So what is t cap? It is tension. What is tension? Tension in the string, like this. Because when you suspend a pendulum from the S point to the mass, then tension is acting toward the point of suspension, like this. Okay. Tension is like this along this side, T. And we will calculate this T cap by using the formula of two-point system. So what are two coordinates? S point is fixed here. The coordinates for S point are 0, 0 and this length is Z. Okay. Because this point is lying on the Z axis. You know that on Z axis, x is 0, y is 0. So the coordinate of S point is 0, 0, Z. And the coordinate of A point, because A point is movable, it is moving like this. A point not stable, it is moving like this. Sometimes it is occur at here, and after some time it will go here, here. Ultimately it will rotate. So the points coordinates of point A are x, y, and z. General coordinates we will consider at point A. Okay. Now t cap is equal to, this t is t, and t cap, what is t cap? It is basically as cap, okay. A to S, this one, because it is acting towards the point of suspension. So t cap direction is A to S, as cap. T cap is as cap. So what is as cap? As cap is nothing, it is t into as vector upon as magnitude. You know that any unit vector can be written as its full vector upon its magnitude. Okay. So as vector, what is as vector? This as vector. So as vector, we will use 2-point formula, coordinate system. This is x2 minus x1, 0 minus x, 0 minus x over this length L, okay, plus, if we are not taking its magnitude, then as vector is 0 minus x into I. Similarly, 0 minus y into j plus z minus z, sorry, it is L, length of pendulum is L, L minus z into k. Is it clear now? Yes. The coordinates of S is 0, 0, L and coordinates of A are x, y, z. By using 2-point formula, x2 minus x1 into y, y2 minus y1 into j, z2 minus z1 into k. Okay. So this is as vector, or it is minus xi minus yj and plus L minus z k. This is as vector. This one. So what is as magnitude? As magnitude. So A to S, this is length of pendulum, it is L. Therefore, this t vector is equal to t magnitude into as means minus xi minus yj plus L minus z into k over AS, that is over L. So this is the components of T vector. It is clear? It is T magnitude into T direction. So we have found the direction by using the concept of 2-point formula. Now we will put all these values in equation number 1 and we will get the final equation. So putting all these values in equation number 1, we will get m into A is equal to minus, because it is mg, m into minus gk, and second one is tension is this, plus T over L, okay, T over L into minus xi minus yj plus L minus z into k, and minus 2 m omega cos lambda into j plus omega sin lambda into k, it is omega vector, and cross multiply with x dot I y dot j plus z dot k. So this is the main equation which is obtained from equation number 1. So you can also find the cross product of two vectors, that is we can find omega into v by using determinant method, I j k, and components of omega is, first there is no I component and it is omega cos lambda, it is omega sin lambda, and similarly v, it is x dot y dot z dot. So you can find the value of this determinant, I into this one, j into this, and k into this. You can also find the value from here and put the value here. So this is our main equation which is obtained. So we will study this rest part in next lecture. Okay, thank you very much.